one last simple thing to do. And our last simple thing to do is determine the actual value of the leading coefficient, not just determining if it's positive or negative. It actually has a value. So this is the most often forgotten part. And it's so simple. So far, we've only been dealing with leading coefficients and caring if they're positive or negative. Now we're going to consider them as real numbers. So here for an example. The graph of a third-degree polynomial function p of x is shown. The graph has integral roots and passes through the point 4, negative 12. Find the equation in factored form. So first thing I want to address is this word, integral roots. All it's saying is the roots are integers. Okay, we're not decimalizing these. We're not trying to trick you. We're telling you those are integers. It's exactly at negative 2, 0, and 6. It's not slightly off. They're integers. Now, if I give you a point, what am I always giving you? An x value and a y value. So anytime it gives me a specific point, I'm thinking to myself, that's an x and a y that I'm going to be able to plug into my equation. So let's set up what we do know. I have some unknown a value. I know it's positive, but I really don't know anything else about it. I have one root happening at 0, so I tend to put that one first. I have one root happening at negative 2, so that gives me the factor of x plus 2. And I have one root happening at 6, creating the factor of x minus 6. Are we all okay where that came from? Well, if I gave you a point, what did I give you again? X and y. If I plug in x and y, the only thing I don't know is a. Substitute all your x's for 4, substitute your y for negative 12. Clean it up. Let's see here, that's going to be 4 times 6 times negative 2. 4 times 6 is 24. 24 times negative 2 is 48. So I've got negative 48, giving me an a value of 1/4. So for some reason, 50% of students, by the time they get to tests, seem to forget to consider that leading coefficient of a. They think about the leading coefficient when they tell me it's positive or negative, but you seem to forget that it actually has to be represented as a value. So just make sure you're considering that a value. It could be 1, but if I give you a point, I want you to set it up to solve for that. Now, if I type my now solved, fully factored equation, if I put this into my graphing calculator, can I verify that I've got the right equation? So it gives you something nice and easy to check. So if I give you a point, always think to yourself, they gave me x and y for a reason. Normally, I'm just substituting it into the equation. And that's how you find the a value. Does it make perfect sense? It's not hard, it's just more. Okay, I can give it to you in a written form instead of a graphical form. A 4th-degree polynomial passes through a point. There's x, there's y. I'm going to use those in the equation. So you really need to connect in with why we give you a point. It has zeros of 1, 4, and another 0 at negative 3, which is tangent to. Okay, if it's tangent, it's going to have a degree of 2. And I know it's 2 because we said it's a 4th-degree polynomial. That's how I know it's not at 4 or 6 or 8. So I restrict the kind of what the degree can be. Determine the equation in factored form. All right. Get into the habit that when we start writing the equation, the first thing that goes is that leading coefficient. Start with that a value. It's so important. I have zeros at 1, so its factored form is x minus 1. At 4, so its factored form is x minus 4. And at negative 3, and because it is tangent It's a degree 2, a multiplicity of 2, an exponent of 2. All right, gave me a point. 54. Nice job with that 54, Mrs. Relic. Try again. 54 is equal to a negative 2 minus 1, negative 2 minus 4, negative 2 plus 3 squared. Just plug in your x and y's. 54 is equal to a times negative 3 times negative 6 times 1 squared, 18a. I solve algebraically and get an a value of 3. It's just running numbers after a certain point. I write my equation in factored form. And would definitely plug that into my calculator and check my points. Make sure it all looks correct. But there's not much to this. It's just more. Any questions so far, though? Is that making perfect, absolute, utter sense? It's very logical. So let's see. Oh, I didn't erase that. Close your eyes. Don't look. Ah! Okay. Let's see if you guys can do this one on your own. It's so simple. I believe in you. I believe you guys can do this. Read. It says lowest possible degree, so I'm allowed to assume things like a 3 instead of a 5 multiplicity. So I just pulled out the multiplicities above the roots for myself to show we're all okay with that. Now, what didn't it explicitly give me? Didn't give me a point, but can I interpret a point for sure off of that? Especially when it says the intercepts are shown. I mean, that's the only thing that's indicated on the y-axis. So that's showing you that point. Oh, what did I do? Oh, it's 2. Thank you. I'm tired. Appreciate it. Thank you for catching me. So now that I have an explicitly shown point, it's the only thing indicated. I know that for sure. I can plug it in. So negative 8 will equal to 8. It's negative 2. So A will equal to, leave a half. All right. It's positive, so I know it's looking good because I know the leading coefficient needed to be positive. Then I would shove it in my graphing calculator and verify it before I moved on. Simple mistakes can happen at this point because, as you just see, you kind of stop paying attention to some things. Yes? Did I do X? I'm tired. Thank you. All right. How are we feeling? Better than me right now? Can't wait to go home and go to sleep. Okay. Just one more, and then the next example is a little bit of a discussion. So why don't you just show me you get it? And I'm going to see if we've got that, that one student that always does something differently that I have to address. That's the next question. This really isn't challenging. All it is remembering to consider that A value and plug in a point. That's it. All right, before we do the question that requires just a little bit of discussion, are we feeling confident on this? Yeah, just don't forget the A value is there. Okay. The next one. This seems easy, but there's always one kid, right? Actually, the last class didn't have one kid, which was kind of cool. Polynomial equation has the following three roots: -2 with a multiplicity of 1, 5/3 is a root with a multiplicity of 2, and -4/5 is a root with a multiplicity of 3. The graph of the corresponding polynomial function has a y-intercept of 400. Determine the equation in factored form. Now, most of you are reading that going, why is this a discussion? Well, let's run the experiment. Let's see if we got that one kid in here. Go ahead. It's not a trick. I'm not trying to trick you. But it's always interesting to see who's the one who does the one that makes me want to cry. Now, without me showing you the work, most students will get an A value of 1 over 8. Who got 1 over 8 as an A value? That is way fewer than I thought. Those few students will get an A value of 1125 over 8. Did anybody get that one? What did the rest of you do as you just sat there? For me? I know, but I'm jumping over something to say. I'm going to get a difference in A value for these questions. I said I'm jumping over the work, and when I determine the A value, most students will get this. There's always one who gets this. Let's try this again. How many got an A value of 1/8? Okay, so there's a few more people are answering. Who got this value? Okay. Now, do you think Holden is wrong? Yeah. I don't think you are. You thought differently. And we're going to have a discussion about what is right. You're both right. What's more right? And I know, this is fun. If you got 1 over 8, you set up this equation going, I have an A value, because you're smart about that, x plus 2. We're all okay with that? Now, if you got 1 over 8, you took this root and you said it's 3x minus 5. And then you took this root and said this is 5x plus 4. And that's what you use to find the A value. Look familiar to most of you? What did Holden do? Not that. He did this. He said this is going to be x minus 5/3. This is going to be x plus 4/5. And that's how Holden got that A value. Is he wrong? No. It's not technically wrong. If I plug that in as the A value and graph it, would it have all of these characteristics? It does. He keeps going, I don't know, but he's right. If you did it this way and had your A value of 1/8, you had all the same characteristics. So the question becomes, which one is the better way? They're both technically right, but I would certainly lean more one way to the other. Do you want to try, Nick?
The better way is the one on the left.
Because?
Because that's what you mark right on the test.
I would actually mark both of them right.
That's crazy.
I would. But the math person in me cringes a little bit at this. Okay? You know, okay, did you apply all the concepts I taught you properly? 100%. Is he technically wrong? No, his graph will have all of these characteristics. So he fits the parameters. But we technically really do not like ever having fractions in our factors. So the fact that it said factored form, I prefer this. Does that make sense? Now, if he multiplied this by 3 and pulled it out, he would get that same leading coefficient. I like this way better, but I would mark you correct on a test. You did a graph that has the exact same characteristics. But typically, guys, we do not like fractions in our factors. And that is normally the first lesson in calculus where I weed out a bunch of you. We start doing some more complex factoring on day 1 to avoid this in the future, and you guys just go, I have no idea what's going on. But the calculus teacher in me detests this. But it's not wrong. But that's what I want to see. So there's always that, thank you for being that one. I truly appreciate it because it helps me explain the process. Okay, so please try to write it in this form. I would appreciate that. We don't like fractions in our factors. Yes, Max?
This equation has a degree of 6, though, if you add the multiplicities.
Oh, I jumped. Okay, so it has the following 3 roots. It's a degree 6, yep. Again, I was so excited to talk about the differences, I forgot to put my base on, my multiplicities on. All right, Guys, that totally wraps up chapter 3. Your test on chapter 2, square root functions. Don't forget about your square root functions. 2 and 3 will be on Wednesday, which means on Tuesday, because you have Monday off, we're going to do a nice written response diploma style question together. Actually, Mr. Chandler is going to be in for me. My daughter has an ortho appointment, so Mr. Chandler is going to come and be here to answer all your questions. So he's going to take my sub, so you guys have an expert in the classroom that can help you prepare for the exam. But you're going to have 3 hours of review because I taught you everything, all right? Perfect. Test is on Wednesday. We're probably going to get into it pretty quick because if you guys had 3 hours the day before, do you need much time when we start up? I'll give you like 20 minutes to ask last minute questions. All right, guys, that's the plan.